Okay, we just went over proving a triangle using our slope. We're going to prove the exact same triangle using a distance formula instead. Okay, so this question reads, prove it's a right angle triangle. We already have quite a bit of the information here. Now, we solved it in the last one. We proved that this was a right angle triangle. That's fine. We're going to use these coordinates again. The way we're going to go about doing this, so we'll start with an overview, is I'm going to use my distance formula. If you guys remember, that's the root of, and it's very close to Pythagorean's theorem, but it'd be Pythagorean's theorem for every single line. x2 minus x1 squared plus y2 minus y1 squared. So here's our distance formula. What we're going to go about doing is we're going to solve this distance here, and then this distance here. Once we have that, we're going to plug in the values. We'll make them up. We'll say this is 5, 4, and 3. We're going to plug them into Pythagorean's theorem and see if they work. If they work, that means this must be a right angle triangle, because the only way Pythagorean's theorem works is if we have a right angle triangle. If we plug them in and we find the left side doesn't equal the right side, then this cannot be a right angle triangle. So we got to find the distance of every single line. So the very first line I'm going to start with is, we'll start actually with CA. Okay? So line segment CA, the distance of it is equal to, and we'll do a different color for each of them. Now if you notice, I've designated these x1, y1, but this one is also x1, y1 because we're using it to solve CB, and then we use it for AB. So I'm going to rename this one. This one will be -3, -1, and this will be our x1, y1. And in this case, this will be 5 and 5, and this will be our x2, y2. Okay? So if you notice, remember I talked about this before, this coordinate here, I've called it an x2 in one case and an x1 in the other. It doesn't matter what we call x1 and x2, just as long as we stay consistent. So I'm going to use the green letter in here, or the green font, to do my distance formula. So x2 in this case is 5. And we're going to subtract x1 in this case, which is -3. So we're subtracting -3 squared. Plus y2 is 5. And we're subtracting y1, which is -1 squared. Let's do it in green since we highlighted it in green. D is equal to the root of, what is 5 subtract -3? 8, that's right. So we have 8 squared. Plus, what's 5 subtract -1? 6. Good. 6 squared. D is equal to, what's 8 squared? And what's 6 squared? Add them together, what do you get? What's the square root of 100? Good. So we just discovered that this line here is 10 units. Okay? That was our very first step. I have to do the other two lines using the same stuff. So our distance formula, we'll do red for line CB, okay? Since I put those points in red, line CB, and that way it's a little easier to read. Since you should already know the formula, what's the first coordinate I'm looking for? Which one? X2. So we look for x2. 1, subtract, what is our x1? -3. Then we square it. Then we're looking for -3, which is our y2. Subtract y1. Very good. We'll go through this quickly now. The root of, what is 1 subtract -3?
4.
Good. And what is -3 subtract -1?
2. -2.
Yeah, it's -2. Okay. Squared. D equals 4 squared is -2 squared.
4.
Positive or negative? It is positive 4. Whenever we square a number like that, we get a positive answer. And in the end, we get root 20, which is some decimal number. Okay? I'm going to leave it as root 20 for now, because it'll actually be very simple to put into Pythagorean's theorem. And finally, the last distance we need to solve is AB. I'm going to go very quickly here. Okay? we're looking for x2 first, which in this case I did the blue points already, is 1 subtract 5 squared plus y2 is negative 3 subtract 5 squared. D is equal to the root of 1 subtract 5 is negative 4 squared plus 3 subtract negative 5 is negative 8 squared. Negative 4 squared is 16. Negative 8 squared is 64. That becomes 70, 80. D becomes root 80. Okay. So we found these distances here. This became root 80. And this one was root 20. To prove it's a right angle triangle, we said we know that Pythagorean's theorem must work. So c squared equals a squared plus b squared. In other words, we have our left side of the equation and our right side. We need them to both be equal since we have values for a, b, and c. C has to be the hypotenuse, which in this case is 10 units. Okay. So we plug 10 units in for the hypotenuse squared is equal to, and a and b doesn't really matter. We're going to call dA, so root 20 squared plus root 80 squared. Okay? What is 10 squared? 100. What is root 20 squared? It's just 20. The square root and the power of 2 cancel each other out. And then the same case happens for that root 80. And what is 80 plus 20? 100. So, both the left side and the right side equal to each other. Therefore, we know Pythagorean theorem worked for this triangle. So this has to have been a right angle triangle. Pythagorean theorem wouldn't have worked either way. The other way we did this was far faster, but just realize there are many ways to prove these geometric proofs. Any of them will work, whatever you feel most comfortable with.